Good morning. Yeah, so any questions before we start? So we were discussing about the scheduling. We were discussing about, so how SQL OS works. So any questions before we start? Scheduling part is done, so I don't want to go into more details about the scheduling, but yeah, that would be sufficient for us to understand. So we'll go with SQL Server Memory, and so how that works. Like we'll go with few troubleshooting scenarios as well for memory utilization or memory leak or insufficient memory. So we will discuss more on memory problems. Right. So any questions before we go on scheduling?
No, Chandra.
Okay, cool. So no questions, then we'll go with memory. Okay. So we must, so work on memory issues or memory troubleshooting, so scenarios and how that memory works and all right. So we will go a little more and understand the basics and, so into advanced, like, so how memory, why memory is required for SQL Server and how SQL Server utilizes the memory, right? Um, if you have any questions, stop and ask me so that we will discuss more or will explain in a better way. Okay. Yeah. So we have few troubleshooting scenarios, like, so I'll show you like how to investigate further, how to use our different tools to identify the memory issue. For example, let's say uh, SQL is not coming up, not starting up because of some memory issues or memory dumps are generating, right? So DBCC memory status. So I will explain and I'll show you all these memory related troubleshooting and all. And buffer pool, like, so you must have heard buffer pool, right? Like how that memory, how that utilizes the memory. And say important thing, like, so you must have seen in SQL error log conventional memory, or you must have recommended to use log pages in memory model, right? Why that is required, log pages in memory model uh, in SQL Server. For example, if you go here, SQL Server, sp underscore read error log, use log pages in memory, right? So what is this and how that is beneficial, how SQL Server is beneficial with this, right? So why we suggest to use log pages in memory to the, so users, to the customers and all, right? So we will discuss that. And yeah, so we'll discuss all these areas, Numa and SQL Server, how Numa is, so how Numa is important, and how that is relevant or related to SQL Server. Few memory concepts and architecture and memory nodes and all, memory models and all, troubleshooting scenarios, right? So we will discuss. Why don't this go away? It's like, hmm. Okay, so how this is important, so what is a Numa? Numa is nothing but non-uniform memory access, right? For example, let's say you have a high number of CPUs, Numa node. So we call that as a node of computers. I mean, collection of not computers, collection of CPUs. We call it as a Numa, right? So what is Numa? Numa is non-uniform memory access. So what is that? I will tell you. But before Numa, so how that works, right? Before, like when there was no Numa, so it was called semantic multiprocessing, right? So you must have heard Numa, right? So for example, if you see, mm, select star from sys.dm underscore os underscore nodes. So this is voice nodes is a DMV to identify how many nodes we have, right? So if we don't have any Numa configuration, so let's say I don't have any Numa is at hardware level, right? So if we have not configured, I mean, if we cannot configure, that should be come with the hardware, right? CPU, motherboard, and system, it should come with. If you don't have any Numa, so we consider that as node 0, right? Numa node 0. And 64 is for only DAC connection. For example, let's say everything is stuck. So we are unable to connect to the SQL server. We are unable to, so log in. So if you're not able to do anything, so we have an option to connect through DAC, dedicated administration connection, right? So how the DAC works, it will be using a different scheduler and different nodes, right? So that is the reason even all schedulers are busy, or all schedulers are not letting so any threads to execute. So this will execute the threads, this will allow it to execute the threads. This as in like node 0, node 64, that is for DAC, right? So if you want to see how many schedulers and how that is aligned to Numa, select start from sys.dm underscore os underscore schedulers. This is the DMVs. Right? So see here, visible online, and if you see that node somewhere it should be there, CPU ID, not parent node ID. See, parent node ID, only this scheduler, only uh, this scheduler is for DAC, right? So 64 Numa, and so this is the only one scheduler aligned to this CPU node, this Numa node. So all are 0, right? So all are 0 is nothing but for only I have only one Numa node, and these are all other CPUs are allocated. Even though these are hidden online, if you see that hidden online, what does it mean? So these are not visible, but only few background threads or few backup threads and all will be running on the hidden online schedulers. It will not be executing on the visible online schedulers, right? So these are all hidden schedulers. We don't have these many schedulers. It is just so showing that hidden, right? So we have only 4 CPUs, right? So these are the DMVs where we can check. So this is again like this is kind of Numa configured hardware. We can add another Numa as well. But what we were talking about, what if we don't have any Numa configured systems? I mean, what we don't have any, you can consider this also Numa, not Numa configured systems. Let's consider. So how the memory will be accessed, right? So this is kind of, so let's consider, one sec. Hmm. Let's consider this is a 10 GB memory, right? So this is 10 GB memory we have. So this is 10 GB memory we have. Let's say this is 8 CPUs we have configured to configure 8 CPUs we have on our computer, right? So every CPU we will be scheduling. So the threads will be executing on every CPU, right? So each CPU, individual thread, a single thread will spawn and execute on the CPU, right? So while executing these threads, it needs memory, right? So to execute the threads, the individual thread needs some memory to execute the query. right? So let's say you are executing select statement. If you are executing select statement, the thread which is executing the select statement, it needs some memory to allocate or to memory to execute the query. How that memory will be accessed? So this memory will be accessed from the this part, right? So from this zero, right? So the same I mean, another thread also will be accessing this memory. Another thread also will be accessing this memory. So every thread on all CPUs will be trying to access the memory from the same place, right? What if this memory, if this is a single point of, you can consider as a memory allocation area. So everyone trying to access the memory, and what if this memory, so is busy, right? So there are chances. I will tell you in this way. Right. Let's consider that this is the memory, right? So this memory, so we have accessing ID for memory, like memory, how the memory will be accessed. So memory, it contains the memory address, right? So let's say consider 100. This address is 100, 101, 102, 103, right? Some four addresses we have, or some certain addresses we have in a sequence order. This CPU trying to access this address, and this will be allocated. This CPU has to identify whether the address is already in use. If it is not in use, then only we should go. If it is in use, then it should go to next. So next one, next one, next one. Likewise, the memory address will be trying to identify the memory address will be busy. I mean, will be delay, because we are accessing only from the single point of contact where all threads are trying to access the memory, right? So if you don't have a Numa, then this is only a single point of allocation. What if we have 30 CPUs? What if we have 64 CPUs? What if we have more CPUs, right? So the allocation and accessing will be very much slower, right? That is the reason we have Microsoft came up with, so it's not actually a Microsoft design. So it is a Intel, or it is a hardware developer design. So how they configure this Numa configuration, right? So that is, they introduced a Numa configuration. So initially it was introduced by the Intel, so Intel team. So while developing the motherboard, so they have configured non-uniform memory access. How this works? See here, instead of so allocating all CPUs together, I mean, instead of grouping all together, all CPUs together, what we are doing, so we are grouping, we are dividing the number of CPUs into multiple groups. We call it as a Numa. Node 0, this we call it as a 0, this we call it as 1, right? So it depends on how many nodes we have. So the number of CPUs will be divided, so that if we have 32 CPUs, the 32 CPUs can be divided into so 8 into 4. Like each Numa node we can configure 8. We as in, like, again, like, so SQL team will not configure. While configuring the hardware, so CPU, it should be configured, the nodes and will be configured hardware level. Right? So here in this case, what happens? So this 4 CPUs will be divided into one group, and this 4 CPUs will be divided into another group. Now what happened? The memory will be also divided equally, right? So this memory also will be divided equally. Now this is 5 GB, the equally divided. 5 GB, right? So the memory will be divided, and these 4 CPUs will be accessing memory. These 4 CPUs will be accessing memory, and these 4 CPUs will be accessing memory from this particular memory area, right? So that the memory accessing would be much faster comparative to semantic multiprocessing in Numa node, right? Because it is considered as a local memory access, right? So local to this particular 4 nodes, instead of accessing a single point to every CPU. Here we are dividing into multiple groups, whereas it is accessing locally, right? So this foreign memory, for example, let's consider this 5 GB is not sufficient to allocate memory for the threads, right? So these memory allocation are almost completed. 5 GB is reached. We need additional memory for the threads. We have more threads, we need additional memory to the threads. Then what happens? This will be contacted from here, right? So the memory will be borrowed from here. So we call it as a foreign memory, right? Foreign memory. This is foreign. Foreign is nothing but not local, right? So this is local, and this memory we are taking from the other node. We call it as a foreign memory, right? So I will show you that how it looks like, so for example, so I'll just show you, I'll tell you later as well, don't worry about it. DBCC memory status, control execute. So we have everything here, right? So we have so all memory objects, memory clerks, and everything we have. Let's copy notepad plus plus. Foreign committed, so we don't have anything. Right, so we have only one Numa node, so that is the reason we see only one foreign value, right? So we don't have anything. Just a moment, let me see. Hmm. So here, this is what we were discussing about foreign committed. If we have a multi-Numa node system, if one Numa node needs memory for its local threads, it will be taking memory from a different Numa node. Is called as a foreign memory, right? So this is how the memory accessing works in a multi-Numa node systems, right? So the memory for like memory access would be faster, and there won't be any issues while accessing the memory. So this is so logical structure, logical for SQL Server. So as we know, CPUs and schedulers, how it is aligned with each other, right? So CPUs are at the physical layer, whereas don't worry about the trace flags, and also you can ignore that. um, so this is not needed, like so if you don't want to use a Numa detection, so we can disable this using this trace flags. But yeah, don't consider that at this point, or don't ever use that, because in your production or anywhere, sometimes like so if you configure Numa nodes, and it might also cause some performance issues. In that scenarios, probably we can disable that Numa, right? That is absolutely fine. And this is the logical layer, right? So this is the logical layer at the SQL Server. That is what I have shown you, system_d_os nodes. This is aligned. So control D, execute. So online and online DAC. So we have only one Numa node. This will be allocated one-to-one relation with the physical server, physical Numa node, real Numa node, and this is the logical. That is what it meant to be. Memory node per physical nodes only. Yes, SOS for each memory node. SOS node. SOS is nothing but SQL OS node. Node is nothing but collection of CPUs. So I will not go much into the 32-bit Windows architecture, but for now, just it doesn't matter whether it is a 32-bit or 64-bit. So these two are common, right? So we have a kernel mode and user mode, right? So the threads which are running at the user mode, we call it as a user mode scheduler. And so kernel mode is below that user mode. Like we have Windows operating system level, kernel level, so we have some threads, right? Whenever we execute any threads, it will be going into kernel mode whenever it is needed and execute those threads, right? So user mode and kernel mode. So normally you must have heard 32-bit. What is the memory architecture for 32-bit? So maximum it supports 4 GB. That I'll talk that. So for now, understand that we have two modes. One is user mode and kernel mode. Any application running on the Windows operating system, right? So we call it as a user mode. And for your understanding, this user mode and kernel mode is not only for Windows operating system. Even you go with Linux operating system, we have user mode and kernel mode, right? So that is Linux kernel mode is somewhat different than this, but so understand that user mode and kernel mode is exist even in any other operating systems as well. I don't know Mac and all, but at least Linux and Windows operating system, we have user mode and kernel mode, right? So user drivers, applications consider any application, notepad.exe, SQL Server.exe, uh, Paint, MS Excel, MS Office, anything we consider it as in the user modes, uh, user mode, not scheduler, user mode, right? Virtual address space. What is virtual address space, right? So virtual address space is nothing but the virtual layer, right? So virtual layer between the physical hardware and SQL Server. Let's consider this scenario. I will explain. So that is important while allocating the memory. Let's consider this is your SQL Server, right? So we need, we have 1 2 3, let's consider 3 threads we have, right? It needs memory, it needs a memory. This is a physical memory. So we have something called VAS, virtual address space. So this virtual address space is the interface between your SQL Server and the physical memory. Whenever we allocate SQL Server memory, it will be allocated through the virtual memory, through the virtual memory. I will tell, like, so what scenarios we will not use, but mostly SQL Server will be allocating memory from the virtual memory. So I'll tell you what is the advantage. So let's say, as I told you, right? So physical memory, we have physical memory is one RAM you can consider. So physical memory is a RAM. So each physical memory, physical memory, we will have addresses. I told you. So let's consider this is one address, 1 or 2, 1 or 3, something. Let's consider 1,000, 20,000, 30,000, whatever it is. We have memory address where the memory will be allocated to. Right. So let's consider we don't have a VAS, virtual address space. So if you don't have a virtual address space, we have some other application called, mm, we have some other application called notepad.exe. Right. So we have two applications. One is SQL Server.exe, another one is notepad.exe, or another SQL Server, whatever it is. It is allocated a memory for the thread. That memory is memory address 100. This notepad.exe also, it needs some memory. So if it needs memory, what is the guarantee that it will not try to access the same memory address which we have, right? So it is trying to access the same memory address which is already been allocated, but notepad.exe doesn't know that this memory is being allocated. So it is trying to access. It leads to the memory corruption because it is trying to allocate and write into the same address. So it will cause the memory corruption. So that is the reason we have intermediate layer for each and every application in the user mode, right? For each and every application in the user mode, we have a virtual address space. So even notepad.exe, we will have VAS, and it will be going here, and then from here it will be allocated. Now, I told you each and every application, it has its own dedicated virtual address space, right? So now this we have 100. This is 200. This is 300. Let's say this is 400. Now this 100, it needs memory. Then SQL Server will be assigned to this virtual address space address. Then internally it will be converted into physical address pointer, right? It will be converted internally. So then this will be converted internally to another address, right? So it will not be allocated. Then this notepad.exe, if you see 100, 200, and this 100 and this 100 is different because this is its own dedicated virtual address space, right? So this 100 and this 100 is different, and this address will be converted. This will understand that which addresses are available to the physical memory to access. This will be converted and allocated to this 3000, right? So this will manage, the virtual address space will manage which threads